Hello everyone, my name is Khamzin Olzhas, and today I'm going to get an interview from the special guest Turarbek Zhanibek.
Hello everyone.
And today me and Zhanibek are going to discuss about an industrial process of creating sulfuric acid. First of all, I think we need to talk about the author of this industrial process, whose name is Johann Glauber. Johann Glauber is a German-Dutch scientist that invented sulfuric acid in the 17th century by burning sulfur together with saltpeter, potassium nitrate, in the presence of steam. Product of this process, as you can understand, is sulfuric acid. Now, Zhanibek, answer me this question. Why is sulfuric acid so important?
Okay, Olzhas. Sulfuric acid is an important product because it is used in many industries, such as manufacturing explosives, battery manufacturing, production of other acids, and also the production of the phosphate fertilizers. Also, sulfuric acid is considered the most produced chemical in the world except water.
Very interesting. Also, I read in New World Encyclopedia that in 2001, the world production of sulfuric acid was 160 billion tons, and the approximate value was $8 billion.
Okay, now let me present to you, Zhanibek, and our audience the global problem that is being solved by sulfuric acid. Sulfuric acid solves a global problem of non-recyclable, highly cost-effective and non-rechargeable batteries that is on lithium. Lead battery is a battery that 37% consists of sulfuric acid, and this battery is one of the most used type of batteries because of these properties and characteristics like ability to get recycled, cheap in production, and ability to be recharged. Now let's talk about the most important part of this interview, and it is how sulfuric acid is made. I have no idea how this process is done, so Zhanibek, tell us about this.
Yes, I would like to do so. Sulfuric acid is applied in a wide range of aspects of society. In metal treatment, for drug manufacture, for paint, for making fertilizers, and for making explosives, according to Fiberglass Products Company. It is obtained from local refineries where it's been recovered from oil and gas. It is transported by tankers as a liquid at around 140 degrees Celsius. The liquid sulfur needs to be sampled before being stored for acid production. The second raw material of this process is air, which is taken from the atmosphere. In order to burn sulfur, it is sprayed into a furnace where it burns in the dry air. Sulfur combines with oxygen in the air to form sulfur dioxide. S plus O2 equals to SO2. The gas mixture which leaves the furnace contains sulfur dioxide and enough oxygen for the next stage. In the converter, sulfur dioxide reacts with oxygen to produce sulfur trioxide. 2SO2 plus O2 equals to 2SO3. In order to increase the rate of the reaction and generally make the reaction go faster, vanadium peroxide, which is V2O5 catalyst, is required in this process. It is highly effective at a temperature of 420 or 460 degrees Celsius, at which the main chemical reaction occurs. Typically, the converter is built in such a way that it includes 4 different beds, and thus 4 stages of converting sulfur dioxide to sulfur trioxide. At some factories, the converter includes more beds in order to obtain a slower conversion process and thereby get rid of impurities as efficiently as possible. According to Fiberglass Products Company, there are 4 beds of catalysts in the converter. The first catalyst bed converts about 63% of the sulfur dioxide to sulfur trioxide, and heat is produced. Before each next converter bed, the gases are cooled down to increase the efficiency of the conversion. Hot gas superheats steam from the furnace boiler. The gas stream passes through 2 further catalyst beds, and the percentage conversion increases. By the third bed, about 99% of the original sulfur dioxide are converted into sulfur trioxide. The fact that the heat is released during the reaction means that the process of conversion of sulfur dioxide into sulfur trioxide is exothermic. Then, the absorption process takes place. The gas stream is directed into the base of an absorption tower filled with ceramic material. After passing through the third catalyst bed, a stream of hot sulfuric acid flows down the absorber, where it meets the rising gas. Acid concentration rises to around 99% as a result of the reaction between sulfur trioxide and water. SO3 plus H2O equals to H2SO4. However, not all the raw materials were completely converted from the sulfur dioxide to sulfur trioxide. There still had remained some of the sulfur dioxide and oxygen in the gases in the base of the absorption tower. These gases are run through the fourth bed of the converter once again, after which approximately 99.5% of the sulfur dioxide has been converted into SO3, according to Fiberglass Products Company. When sulfur trioxide is dissolved in concentrated sulfuric acid, oleum is formed, which is H2S2O7. This sulfuric acid is then diluted with water in order to get sulfuric acid back. This added water increases the overall volume of the acid. This industrial process produces large amounts of heat, and that heat is used to boil water. As the water reaches its boiling point, it starts evaporating, producing steam needed to generate electricity, which is then sold to the national grid.
Wow, this is amazing information. I never understood how this process works, but now you opened my eyes to this topic.
Okay, Zhanibek, as you already talked about the process of creating sulfuric acid, now let's talk about the advantages and disadvantages of creating sulfuric acid from, let's say, economical and environmental factor. Okay, let me start from the advantage.
Sulfuric acid is the second most created chemical besides water, and because of this it generates 8 billion of US dollars to the world economy, which is a beneficial for the economy of any country in the world.
Also, sulfuric acid is produced from sulfuric dioxide, a significant air pollutant which lowers overall emissions. So I stated all the advantages, and now let's talk about the disadvantages. The cooling and absorption phase of the creation of sulfuric acid requires a big amount of water, which could ruin the storage of water on local water supplies. Also, I think due to the extreme corrosiveness and toxicity of sulfuric acid, the soil and water that contacts with sulfuric acid pollutes the soil and water. The creation of sulfuric acid produces pollutants like carbonic mist and nitrogen oxide, which contribute to acid rain that harmfully affect the environment. Because of high temperature and pressure that is required in this process, a large amount of energy is used. Because of this, the greenhouse gases occur that negatively affect the air and climate change. So in order to conclude all of our interview, let's answer 3 basic questions.
Zhanibek, what is the probable future of this industrial process?
The future of sulfuric acid manufacturing seems to be quite promising and expects rapid growth by 2029. According to Modern Intelligence, the market size of sulfuric acid production is is estimated to be at 321.05 million tons in 2024 and expected to reach 384.25 million tons in 2029, growing at the CAGR, compound annual growth rate of 3.82% during the forecast period. The high demand for sulfuric acid in phosphate-based fertilizers and the growing demand from the chemical and pharmaceutical industries around the world.
Are new methods and catalysts being tested?
According to Turarbek, February 5, 2024, new methods and catalysts are indeed being tested. For instance, DuPont Clean Technologies introduced 2 new sulfuric acid catalysts, Max Super Gear and Max XLP 310, which build upon its well-proven gear and XLP catalyst product lines. These catalysts aim to help acid plant operators increase conversion and improve environmental performance with minimal investment. Other developments include the use of ion exchange resin, supported heteropolyacids, zeolite, silica, enzymes, and metal oxide catalyst, according to Felicia et al. 2021, December 17.
What is the likely effect of the economy and environment? And Zhanibek, let me answer this question as we already discussed previously. The environmental effect of creation of sulfuric acid is negative because of toxicness and corrosiveness of sulfuric acid that can damage water and soil. However, the creation of sulfuric acid is beneficial for the economy because it provides many job opportunities to society and it generates around 8 billion US dollars every year.